Hello students, now we will see about the topic elastic theory of torsion in the unit 2. So in this unit I gave the introduction about the in the last session itself. So let us recall some of the things. So will you please tell me the types of loads which are acting on the structure? What are the types of tensile load, compressive load, torsional load, shear load. Okay, so here whenever the load is acting, it will create some stress and also the strain. So what is the meaning of stress? Force acting on unit area. What is the strain? Changing dimension. Okay, so if you are applying the tensile load, there will be a tensile stress will be created. If you are applying the compressive load, there will be the compressive stress. Same thing if you are applying the torsion, if you are twisting, okay, so it will be subjected to the torque. Okay, so mostly the shafts will be subjected to the torsion. Okay, so these are all the things you should know that. Here if you are taking the types of shafts, in a circular shafts it is classified into two types. One is a solid circular shaft and another one is the hollow circular shaft. Okay, so now we will see what are the topics we are going to see that. So why the torsion equation is important in civil engineering, okay, and what are the applications, and we are making some assumptions for torsion equation. So if you are deriving any equation, we have to assume some of the things. Okay, so if you are taking any material, so we have to go for the torsion. We have to make some assumptions. Okay, so and we will see that what are the terminologies we are using, and we will see the derivation of the torsional equation of the shaft. So now we will see that why the torsion is important in civil engineering. So you can see this. So this is the if you are doing the analysis. So in next year you will study the subject structural analysis. So what is the meaning of structural analysis? If the different types of loading acting on that, the behavior will be different. Okay, you will study in the structural analysis. Same thing you will study in the STAT. Okay, there are so many softwares are there for analyzing the structure. You will study the STAT and the answer. So many softwares are there. Okay, so here this is the model which is taken from the software. If the structure is subjected to the torsion, you can see that it is how it is behaving. And here you can see this. Have you seen this anywhere? So what is this? So this is a steel structure. You can see in our auditorium. You can see that if you are taking this RCC structure, okay, the construction process will be different. Okay, if you are making the joints between the column and beam, we will cast together and we will make the concrete. Same thing if you are going for the steel structure, if it is a beam is there, and if you want to fix it with the column by means of bolt or rivet or weld, we will do the joints. Okay, so here we are using the bolting joints. Okay, so these in these places the structure will be subjected to the torsion. Okay, so this is the reason for studying the torsional equation. Okay, and next one, if you are taking this here you can see the roof. This is the RCC roof. Same thing if you are constructing the steel structure, you can see these types of purlins. Okay, so here this is I section. This I section. If the I section, it is the length of the I section is more, there will be buckling or bending will be happening. So to avoid that, we will fix some bracings. Okay, so horizontal bracings. So the reason is here this portion will be subjected to the torsion. Okay, so if you are knowing about the torsion before designing this component, and we can avoid the failure due to the torsion. Okay, and next one, if you are taking this, this is a lateral force. So what is the lateral force? Wind and earthquake. So that are the lateral forces. In that places also, this there will be the cause of torsion will be that. Okay, so here there also as like as the light load and dead load, we have to include the torsion also. Okay. And next one, if you are seeing the structure, I have given some examples for your understanding, easy understanding. So already just we have came across with the assumptions. What are the assumptions? The material should be homogeneous, which means if you are taking any material, throughout that material, the property should be same. And next one is it follow the Hooke's law. What is the Hooke's law? Stress is directly proportional to the strain. And next one is the shear stress should be proportional to the shear strain. And next assumption is the cross section should be plane. So if I am taking this, just imagine this is a shaft. So if I am making the cross section, it will be a circular. Again, if I am twisting and if I am cutting that and if I am moving the cross section, again it will be a same. Okay, so that's what the remaining three assumptions are confirming that thing. Okay, and next one, if you are taking this derivation, we will first we have to understand the shear stress and shear strain. Okay, so here the shear strain is given by R theta divided by L. So you know the Hooke's law. Here we are applying the Hooke's law. So tau is the shear stress. Okay, and the gamma is the strain. And we are making the stress is proportional to the strain. For removing that, we are introducing one constant. Okay, so that is the rigidity modulus. Okay. So therefore, this is the equation for deriving the torque due to the shear stress. So I will explain in the class detailing. And the next one is the torque for the overall cross section. So this is a final formula for calculating the torsional equation. So if you are taking the torque T equal to tau max divided by R. Okay. So now if you are relating all shear stress and shear strain and angular thrust, and finally you will get a formula as T by J equal to tau max by R equal to C theta by L. Okay, so what is the T? T is the torsion. What is the J? It is the polar moment of inertia. So for circular section, we are using the formula as pi r power 4 by 24. Actually, in our class, we are using in terms of diameter. Here, the equation is given in terms of radius. What is the radius? Diameter by 2 will give the radius. We will use the pi d square by 12. And here, it is given in terms of radius. Therefore, it is a pi r power 4 by 24. And it is a tau max by r. If I am taking the circular section, due to the twist, the torsion is created outside of the shaft. It is given as tau max or simply tau. So the r is the outer radius. Okay. And what is the C? Either we can use the letter C or G. What is the G?
It is
rigidity. What is the theta?
Angle of
twist. What is the L?
Length of shaft.
Length of the shaft. Okay. So this is the formula for doing that. So and finally we will make the conclusion on this. So what is the torque T?
T is
It is given by tau max divided by R into J. And the shear stress is given by
G
G
gamma.
into gamma. That is the tau is the shear stress and this is shear strain and this is a rigidity modulus. Okay. And what is the next? Angular twist. So the angular twist can be calculated by TL by GI. So and finally the torsional equation is, what is the torsional equation?
T by J.
T by J equal to
Tau
tau max by R equal to
G
C
theta
theta
by
by L. Okay. So now we will make some we will see some what are the challenges they are facing while they were designing these structures if it is under the torsion. So it is very difficult to calculate the short corners and also the diameter changes. So for an example, if I am taking this, here diameter is somewhat small. If I am coming to this cap side, the diameter is increased. Okay. So here, if I am doing some assumption, it will be different here, it will be different in this part. So while if I am combining the different diameter, there will be the problem on calculation of the stresses. And next one is the material selection. So the material selection is very, very important. So here there are so many, if I am taking the steel, mild steel, there are so many grades are there. So we have to select the grade of steel depending upon our structure. Okay, you can't use all material for everywhere. So depending upon our requirement, we have to choose the material. If you are wrongly selecting, then the material will be or that structure will be collapsed or it may be subjected to the failure. And next one is the hollow shaft design. So here, if I am taking this, it is a solid shaft, it is very, very easy. But if I am taking the hollow circular shaft, the design and getting some difficulties. Then combined loading. So what is the meaning? So if I am taking this whole structure, you are sitting, you are making the live load, and here there will be a self weight, it is making the dead load. This classroom is in the wind side area, the wind velocity will be more. While you are designing this structure, you have to take all the loads, okay, put together, and you have to analyze the structure. So as like here, if I am taking this these types of structure, we have to take the load, bending, axial and dynamic loads. So this combination of the loading and the analysis also, it is making somewhat difficult. Okay, and next one is the excessive twist. So for an example, if I am taking this small part, if I am twisting, okay, same thing. If I am taking the length is more, the twisting will be different. So if I am going for the length and structure, the twisting and studying that property is also difficult. Okay. And next one, if you are going there, what is the angular twist equation? Already we have discussed. What is the angular equation? So there are three things are given there. So what is the angular twist? Here it is given as T L by CG. And what is the measurement for measuring the strength of the shaft in rotation? It is a polar momentum inertia. So I think in this session you have understood how we are calculating the torsional equation. What is the importance in the civil engineering? So thank you, students.